Module 2, Chapter 1.3, 1.4, and 1.6. The first section is Chapter 1.3, Linear Functions. Recall that a linear function in two variables is an equation such as y equals 3x plus 6. Solutions are ordered pairs of the form x, y, and the graph of all the ordered pair solutions make up a straight line. Now, a function f defined by f of x equals ax plus b, where a and b are real numbers, is a linear function. The graph of f of x equals ax plus b is a straight line and can be found by graphing the equation y equals ax plus b. So if we were going to graph the line y equals 3x plus 6, we're going to plot a set of ordered pairs and draw a line through them. Now remember, because this is linear, the graph will have to be a straight line. So the first thing we're going to do is find some ordered pairs. Now we have just randomly chosen x is negative 2, x is negative 1, x is 0, and x is 1. To find the y values, we take these x values and plug them in. So for instance, if x is negative 2, we'd get y equals 3 times negative 2 plus 6. So y is equal to negative 6 plus 6. So y is equal to 0. This gives us the ordered pair, negative 2, 0. And then we continue for the other three ordered pairs. Now, once we find these ordered pairs, then we plot them on the line. So the first point would be x is negative 2, y is 0. When we go through and graph these ordered pairs, you notice we've got a straight line. So we draw the line that goes through all the ordered pairs, and that represents the graph of the equation. Now, if we were going to graph the line with our calculator, first thing we're going to do is go in and go into our y equals, and we are going to enter 3x plus 6. Now, it's probably a good idea if you go to Zoom 6, which is Zoom Standard. That will give us a fairly friendly screen from negative 10 to 10, which means negative 10 back here to 10 here, negative 10 here to 10 here. So that's what our graph would look like. Now, another way we can graph is using x and y intercepts. The x-intercept is the point where the graph crosses the x-axis. The y-intercept is the point where the graph crosses the y-axis. Two distinct points determine a line, so we can use these intercepts to graph a linear function. Okay, so how do we do this? Well, to find the x-intercept, we are going to let the y value equal 0 solve for x. This will give us an ordered pair of the form the x-intercept, 0. To find the y-intercept, we are going to let the x value be equal to 0 and solve for y. This would give us an ordered pair of the form 0, the y-intercept. And if you'll remember, another name for the y-intercept is b. So once we find these 2 points, then we can graph the linear function. Now, let's talk about where we would ever use a linear function. The function f computes the cost of an X-mile cab ride for which there is a $2.25 charge for the first mile and a charge of 63 cents per mile for each additional mile. This function would be represented by f of x equals 0.63x plus $2.25. Now notice the 63 cents is per mile and x is the number of miles. This is what we call the rate of change. Now the initial value, the $2.25, that is the cost that you would pay for 0 miles. So your initial cost, even if you didn't go anywhere, would be $2.25. Now, the zero of a function is any number c where f of x is equal, where f of c is equal to 0. That is, it's the x value that gives the function a value of 0. Okay, the zero of a linear function is the same as the x-intercept of an equation. Let's say it a different way. If c is a zero of the function f, then f of c is equal to 0, and c is the x-intercept. Okay? So, for instance, if we wanted to let's graph using the intercepts. To graph the line y equals negative 2x plus 5, we're going to not only just pick random points, we're going to pick particular points. We're going to go through the first time, let x be 0, find y, and then we're going to let y be 0 and find x. So if we went through and said, let x be equal to 0, then we get y equals negative 2 times 0 plus 5. So y is equal to 0 plus 5. So y is equal to 5. That's the ordered pair 0, 5. If we do the other way, let y be 0, we get 0 equals negative 2x plus 5. Subtract 5 from both sides, so we get negative 5 equals negative 2x. Divide both sides by negative 2, and we get negative 5 over negative 2, which is 5 over 2, which gives us our x-intercept. Now, when we go through and graph those, you notice 0, 5, that's where it crosses the y-axis. When we do 2.50, that is the x-intercept. Okay? A 100-gallon tank is initially full of water and being drained at a rate of 5 gallons per minute. What is the linear function that models this problem? Now think about this. We've got a tank with 100 gallons of water, and it's leaving at 5 gallons per minute. So our function is going to be negative 5x, which is the constant rate of change, times x, plus the initial amount, which is 100. Now, how much water is in the tank after 4 minutes? Well, once we have our function that computes the amount of water, to find how much water is in the tank after 4 minutes, we would just write that as f of 4, which means negative 5 times 4 plus 100, which would give us 80 gallons after 4 minutes. Then it says interpret the x and y intercepts. Well, remember, to find the y-intercept, we're going to let x be 0, and if we do that, we get 100. That means the tank initially has 100 gallons in it. The x value is 0. No minutes have passed. The x-intercept, we're going to let y be 0, solving we get x is 20. So what that means is, when there is 0 gallons of water in there, then the x value is 20, or the tank takes 20 minutes to empty. Now, We've talked about a linear function. Let's talk about a constant function. Linear was f of x equals ax plus b. If a is 0, if the rate of change is 0, then we get f of x is equal to b, where b is just some real number. F of x equals b is called a constant function because the value of the function does not change. It is always b. A constant function is also called a linear function because it does make a straight line, but every linear function is not a constant function. Okay? Let's practice. F of x equals b, where b is a real number. The graph will always be a horizontal line. The y-intercept will always be of the form 0, the number. The domain, the x values could be anything from negative infinity to positive infinity. The range, the y value is always going to be just that number b. Okay, for example, if we had the constant function f of x equals negative 3, when we graph that, we would say, well, if x is 0, the y value is negative 3. If x is 2, the y value is negative 3. If x is 5, the y value is negative 3. You notice we get the horizontal line through negative 3. Y-intercept is right here. Now let's talk about x-intercept for a second. Where does this graph cross the x-axis? It does not, so what we do is we say that there is no x-intercept. Don't say x-intercept is 0, because then you're implying that it crosses the x-axis at 0. Okay? Let's graph. Graph the function f of x equals 4x. Then give the x-intercept, the y-intercept, the domain, and the range. So, f of x equals 4x, we need some points. So we can do x is 0, x is 1, x is 2. If x is 0, then we get f of, and notation would be f of 0 equals 4 times 0, which is 0. You know what? Let me back up. Because they ask us specifically for intercepts, let's let x be 0, find y. That's the y-intercept. Let's let y be 0, find x. Well, that's 0 equals 4x. Divide both sides by 4, and we get x is 0. So this is a different type. X-intercept and y-intercepts are 0. Now we need a couple more points. So if we let x be 1, then we'd say f of 1 is 4 times 1, so f of 1 is 4. Let's pick another point. Let's pick 2. F of 2 means 4 times 2, which is 8. That gives us plenty ordered pairs. 2 would show us what the line looked like. If we had 0, 0, and 1, 4, we would have an idea what that line looked like. That third point just sort of verifies what we were doing. So now we've got 3 lines, 3 points that line up. So this would be our graph. So x-intercept is 0, 0. Y-intercept is 0, 0. Domain, well, if you notice, the graph goes all the way to the left and all the way to the right. So domain would be negative infinity to positive infinity. The range, if you'll notice, the graph goes all the way down and all the way up. So the range would be negative infinity to positive infinity. Let's do another one. Graph the function f of x equals 2/5 x minus 3. If we know we're going to have to go ahead and find your intercepts anyway, let's go ahead and start. Let x be 0, find y. Let y be 0, find x. If x is 0, f of 0 equals 2/5 times 0 minus 3, which is 0 minus 3. So that would be -3. Second one's a little bit harder. To let y be 0 means we're going to let f of x be 0. So we would get 0 equals 2/5 x minus 3. Add 3 to both sides, so we get 3 is equal to 2/5 x. Multiply both sides by 5 over 2. And we would get x is equal to 15 over 2, or 7.5. So there's our x-intercept and our y-intercept. If we want to go ahead and pick another point just to sort of check it, let's pick something nice. Now, because we've got a fraction, most of us like to avoid the fractions. Let's pick something that would cancel with that 5 in the denominator. So if we pick x is 5, then what that's going to give us is 2/5 times 5 minus 3, which is 2 minus 3, which is -1. Now we've got our 3 ordered pairs. It crosses the y-axis at -3. It crosses the x-axis at 7.5. Over 5 down 1 is another point on the line. We do get 3 points that line up. I sort of missed them, but that would be the graph domain. The graph goes all the way to the left and all the way to the right. So domain would be all real numbers. Range. The graph goes all the way down and all the way up. So the range would also be all real numbers. Now, let's graph the function f of x equals 1. Remember, this is a constant function. So really, we don't even have to do anything. We just say, well, it crosses the y-axis at 1. So x-intercept, it doesn't cross the x-axis, so we say there's no x-intercept. Y-intercept is the ordered pair 0, 1. Domain, the graph goes everywhere left, everywhere right. Range, now the only y value is that 1 point, so I can put it in set notation rather than ordered pair notation. Now, let's talk about slope. The slope of the line passing through the points x1, y1, and x2, y2 is given by the formula m equals rise over run, or sometimes you'll see it as the change in the y's over the change in the x's. But usually you'll just see it as y2 minus y1 over x2 minus x1, as long as x1 is not equal to x2. Now, the slope of a horizontal line will always be 0, okay? y1 is equal to y2, so that gives us 0 over a number which is 0. A vertical line, the x values are the same, so x2 minus x1 is 0, and in that case we would get a number over 0, which you can't do it. It's not a real number, so we say that that slope is undefined. So, a line with positive slope rises from left to right. A line with negative slope falls from left to right. A line with a slope of 0 is a horizontal line, and a vertical line has undefined slope. So if we are looking at a graph and you see a line that does this, always ask, does that line go up or down? Well, in slope, you always look from left to right. So as the line goes from left to right, it's going up. Therefore, that is a positive slope. A negative slope means from left to right, the line is going down. Then we would get negative slope. We'll do it one more time. A horizontal line has 0 slope, and a vertical line has undefined slope, or sometimes we'll say no slope. So let's try one. Find the slope of the line passing through the pair of points 5, -2, and -1, -3. Now, in slope, we label our points x1, y1, and x2, y2. Our slope formula is y2 minus y1 over x2 minus x1. Plug in your values. Y2 is -3, y1 is -2, x2 is -1, x1 is 5. So this line would have a slope of 1/6. Let's try it again. First point, x1, y1, which means x from the first point, y from the first point, x from the second point, y from the second point. Slope formula, now you'll need to know that. We'll not give it to you on the test. x2 minus x1, so y2 is 5 minus y1 is 4. x2 is -2 minus x1 is 1, which gives us 1 over -3. So we would say that the slope would be -1/3. Now, let's talk about graphing some more. Remember, we graphed by plugging in ordered pairs. Well, now this is a different way. Graph the line that passes through the point 3, -1, and has a slope of -3/4. So what you're going to do is you're going to start with this point right here. If it passes through the point 3, -1, that means that is a point on the graph. Now, a slope of -3/4. I'm going to rewrite that as being -3/4. And if you'll remember, this is rise over run. So from this point, we're going to rise -3, which means we're going to go down 3, and we're going to run 4. So there's the second point on the line. So if you look, you can see where that line would be. Now, something that's neat about this is you could also call -3/4 3 over -4, which means from this point you go up 3, back 4, and that's another point on the line. And that just sort of helps to set that line out. So that's what the graph of the line would look like. Now, it's hard to tell x-intercepts and y-intercepts from this graph, but in terms of graphing, the slope is pretty handy. Okay, let's do another one real quick. We've got a point and a slope. So if we're just graphing, we say, well, the point is -1/3. So there's the first point. Now, a slope of 2. As a fraction, rise over run, we've got 2 over 1, which means up 2 over 1. Or the alternative is -2 over -1, which means down 2, back 1. Either way, we get our 3 points that line up to make a straight line. Now, what if we know pieces of the graph, but we don't have the equation of the graph? Okay? Well, there's 2 different ways we can find the equation of a line. The first is the slope-intercept form. Okay, the slope-intercept is y equals mx plus b, where m is the slope and b is the y-intercept. Linear functions are often written in the form f of x equals ax plus b, where a is the slope and b is the y-intercept. Same thing, one uses an m, one uses an a. So, if we were going to do this, we could look at this, graph the line y equals 3x plus 1. Automatically, we know that slope is 3. We know that the y-intercept is 1, which means it's going to cross the y-axis at 1. Well, if slope is 3 over 1, it's 3, it's 3 over 1, which means from this given point, we're going to rise 3, run 1. That's enough that we need to graph our line. Okay? Where are we ever going to use this? In 1984, the average annual cost for tuition and fees at private four-year colleges was $5,991. By 2004, this cost had increased to $20,082. find the average yearly increase in cost between 1984 and 2004. We are looking for the rate of change. So if we graph those and say, well, the first point is 1984 and 5,991. The second one is 2004 to 20,082. And we want to find the average rate of change, then we use our slope formula. This is y2 minus y1 over x2 minus x1, which gives us a slope of 705.55, which means the average yearly increase in cost was $705.55. Now, you're ready to do your homework from Chapter 1.3 on My Math Lab.